Hello everyone, welcome back to my channel. Today let's go over a premium medium question that I just solved on my own. So I'm super happy about this and I'm very glad that I was able to come up with my own solution to this question without any help. So let's go over it and let me show you how I did it. So this is question 3730, maximum calories burnt from jumps. So basically what the question's asking you to do, if you read the examples, which I think completely for me just gave away exactly what they're trying to do, rearrange this in a permutation in which the difference from the last value and the current value squared added together totally is the biggest it can be. So let's go ahead and do that. Permutations of heights. So then we can just go ahead. Okay, did I spell permutations correctly? Okay. So let's call this current, and we're trying to return an integer, okay? So here, for example, 917 is the best, 524 is the best, and yeah, so let's go ahead and for I val in enumerates A. So if I is equal to 0, notice the 0th one, you're always going to just take that value minus 0, so we're just going to add value squared. Otherwise, right, we're just going to add a of I minus the one to the left, whatever this permutation is, squared. Okay, and then once we go through all the permutations, we should have our result, and we can just return that at the end. So this is going to be exponential time complexity squared, which is not great. So just to give you a naive idea of what the question is asking, so let me show you exactly how I optimized it. So let's wait for this to time out. Okay, so what I did is, if you notice the test cases carefully, so if you notice this carefully, notice it's just biggest. The first one is always the biggest, and then the smallest, and then the biggest out of whatever's left. So biggest, smallest, and then there's only 7 left. So here that holds to be true as well. And so let's go ahead and implement that. So first we have to get the biggest. So we want to add SL of -1. So we want to sort heights, create a heap, and then do that. And then we also want to discard, or we can just pop. And then, so now if we look at results, it's going to be what we need. And then depending on the turn, the first turn we want to pop the smallest, because the very first turn, the first index term, we want to pop the smallest because the first turn is always the biggest. So we're alternating turns, right? So let's go ahead and do that. So while we still have elements to process, then if turns is an even number, because we started with even, then we can just pick the smallest one, right? Because that's the turn we picked. So we can go ahead and add SL of 0 squared, and then discard SL of 0. Otherwise, if it's not, then we're going to pick the largest one, the one to the right, since this is a sorted list, and do the same thing. So we're going to discard from the right, aka the biggest number in the heap. And then at the end, we obviously want to increment terms, and we're going to process all the values. And then at the end, we can just return the result. So let's run this, and that's not correct. So let's see what's going on. So if we want to process the smallest one, again, we actually want to take the difference compared to, so we want to keep a stack to keep the most recently used element. So we're going to append SL of -1 to the very rear of the stack, to the end of the stack, right? The end of the stack. And then here, we're just going to actually append to the stack the current value. So we're going to say stack dot append SL of 0, in this case stack dot append SL of -1, and we can actually do that after we calculate the result, because, so let's move this, and we can just say, because there's always going to be something in the stack, so it's not going to be empty, because we already processed that biggest first element for the very first turn, right? So then we can just say we want to add the end of the stack, the most recently used, times SL of 0 squared, right? Because we already added that very first one, that's the exception. And the same thing here, so stack of -1 minus this one squared, right? Okay, so let's run this. So still not correct. Oh, it might be the one we're picking now, minus SL of 0 squared, SL of -1 minus stack -1, stack 0. Okay, so still having some errors here. Oh, stack of -1, right? The most recently used one is the one we have to use, right? So because the stack keeps whatever is going in order, so if we print the stack and result, you can see that we're basically building up that result. So biggest, smallest, biggest, biggest, smallest, biggest, right? So sometimes you just have to observe the test cases and it will give away exactly what you have to do if this description is not clear, which is what I did in this case. So let's run this again, submit it. And there you go, passes all test cases. So again, I'm super happy that I was able to come up with my own solution to this problem without any assistance and solve it completely on my own. So that's it for this video, and thank you for watching.